original design came out like this, where we had sort of a box structure made out of wood, a couple of hanging chimes, and a rotating rod in the middle with popsicle sticks on it that would hit the chimes. That design wasn't very viable and would be very difficult to make. So we ended up changing our design completely, and we came into something like this. Originally, it was just these two standing up posts with this in the middle for support, and the chimes hanging with some sort of connecting rod on the side here.
Looking at our sheet music, we figured out which notes we would need for our song. We used this formula to figure out the lengths we would need for those notes. Using the audio program Audacity, we measured the frequency of each pipe length to make sure that they matched. During the design process, we changed many things about our initial design. First thing we changed was the beams at the top. We wanted to add more structural stability to our design. Second thing we changed was we added in rubber bands to hold the chimes so that they'd resonate more clearly. Originally, we had them as strings. We also had to cut down the length of our chimes so that it would fit in the constraint box. They were too long, so we had to cut them down an octave. We also added in a soundproofing box over our motor out of 3D printed plastic.
Hey guys, we're going to talk about coding now. We chose Ode to Joy because it has 6 notes. By doing so, we are able to use 4 solenoids and 1 motor. And we assigned numbers for each of the solenoids and motor so that we could make arrays based on like quarter notes, eighth notes, half notes, and so on. Using the arrays, we were able to shorten the code, and additionally we used for loops so that it could read each code. Hey, where's Angela? Hey, Angela. Hey.
Oh, hey!
We're talking about coding.
Oh, is this our code for our song?
Yeah, you want to finish it for me?
Yeah, so we realized that setting time for our notes like B flat and C5 wasn't really working, and then we needed a potentiometer to read its positions. Using that, we made another function. We called it motor notes. The function would tell it, hey, for B flat, you need to turn the motor on and go forward or go backwards, depending on the song. Usually when going to position 1, that's where we had problems with the speed, so it would go back to position 1 and it would slow down.
Hey guys, now we're going to talk about That can't be a blooper.
Formula we used to develop the note.
Secure it to the structure. Nah, it sounds weird. I don't like that.
We added into our structural design.
Okay, let's take the solenoids.
So once we put that all together, it worked. Oh, and then we also...
And then we
Class dismissed.